The same from the Ohm's law experiment, we used the switch, the fixed resistors, which has a 1 kilo ohm, 2 pieces, and a 10k ohms, 1 piece. The power supply, 12 volts, the electrical tape, and the circuit board or board. Combining all of these, we can get a series circuit. What we have now is to test the total voltage is equal to 12 volts. So the meter shows that it has a 12 volts. Now let's turn on the circuit. Now let's move down to 10 dCV to measure the voltage drops in each resistors. So what are we going to follow here is the red measurement for the voltage. So in R1 it has a 1 voltage drop. R2 has a 1 voltage drop, and also R3 has a 10 voltage drop. So what we can see here is the Ohm's law has also relationship with the Kirchhoff's law. So from the Ohm's law we can derive the formula to find the current, which is equal to 1 milliamps. In order to recheck the total voltage, we can multiply the current times the 12,000 ohms, which is equal to 12 volts. Also, in the total resistance, we can add the resistance by each resistors, which is equal to 12,000 ohms. Here is our next experiment, which is the parallel circuit. According to the principle of the parallel circuit, it says that the voltage is equal to all the resistors or resistance it dwells. So for the first calculation, to find the total resistance in parallel circuit, the formula is 1 over R sub t is equal to the sum of all reciprocals of the values of resistors. Now we input 1 over 1000 ohms plus 1 over 1000 ohms plus 1 over 10,000 ohms is equal to 21 over 10,000 ohms, or the total resistance is equal to 476.19 ohms. We should know that the total resistance from the parallel and series are different in values. Before we proceed to get the total current, we should know that according to Kirchhoff's current law, it states that there is a conservation of charge entering and leaving a junction. So there are some changes from the current from one resistor to another. What we have here is to calculate the current with respect to the total voltage over the resistance of the first or second or third resistor. In terms of resistor 1, we have 12 milliamps, resistor 2 12 milliamps, and resistor number 3 is 1.2 milliamps. Also, to calculate the total current moving around the parallel circuit, we use the formula total current is equal to the current of resistor 1 plus the current of resistor 2 and the current of resistor 3. Adding those values, we have a total current of 25.2 milliamps. For the total voltage, we have 12 volts because on our parallel circuit, the voltage is well distributed from each resistors. And that's all for our series and parallel circuit experiment.